And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. We're starting things out looking at the sun in colorized magnetogram from the SDO here. 0 sunspots, very weak levels of solar activity in pretty much all measures. And we'll be talking about various other interesting things like a significant earthquake in southern Alaska, near Anchorage actually. A coronal mass ejection watch in place currently. And how about some Panspermia? So let's go out to Lagrange point 5 here at stereo A and take a look at the coronagraph. Here's what's going on from the perspective of stereo A's coronagraph. And the likelihood of a coronal mass ejection has gone up a bit here despite low levels of solar activity because of a large filament, which is looking less and less stable. And we'll show you close-ups of that. Let me advance this. And you can barely see it here. But the point is there's a lot of plasma in between Earth and Sun right now, folks. So here's the view in 171 angstroms. And the filament we're talking about is right up here. We'll show you close-ups of that toward the end of the video. And here's a better view of that in 304 angstroms. And again, we'll zoom way in on this at the end. Tons of stuff to cover, though, today. And that earthquake in southern Alaska was a 5.5 magnitude. Shout out to Brett and to all of our patrons. So, have you heard of reverse werewolves? Well, reverse werewolves are what happen at a new moon. People sleep well, and they stay in instead of going out. They switch to vegan diets, and their hair grows in reverse. Yes, reverse werewolves. You weren't aware of reverse werewolves? Well, that's a thing. Doggone reverse werewolves. And watch out for them, especially at new moon, which is coming. And there's where things will be a couple days after it and 1 week in the solar system. Mercury approaching opposition. Or is it conjunction? I don't remember. In any case, here's a star chart. And if you're up before dawn, you may see Saturn and Jupiter rising ahead of the sun. If you've got clear skies and a view of the ecliptic, the radio flux all the way down to 74, folks. 74 solar flux units. Oh my God, the sun is shutting down forever. Head for the hills. Hide in your bunkers. All right, so here is a 1-year chart from Solon.info. The black line here is the radio flux. The red line is the sunspot number. And so, like we said, not a lot going on, but there is a filament, and the either eruption or collapse of that filament is imminent. So, not a lot to really see there. And by the way, do you follow me on Twitter? If you don't follow us on Twitter, we've got 129 followers on Twitter. Yes, you may not see all the content or have the latest updates unless you follow us on Twitter. I don't really care. I've only started using it in 2019, 2020. I don't even remember. I think 2019. Actually, we've had an account since 2019, but I've only been actively using it since last year. So here's a breakdown of the volcanoes here. Dacono is still erupting. And there's a satellite image of it. You can see looks like a volcanic ash plume here, shown on the satellite. About 40 kilometers in length, it looks like. So about a 24-mile long ash plume there. Popocatépetl exploding in Mexico, 21,000-foot ash plume there. Fuego, 15,000-foot ash plume there in Guatemala. Ecuador also exploding with Sangay, which is producing a 23,000-foot plume of ash. Revenador and Sabancaya in Ecuador and Peru, respectively, both exploding as well. Revenador 15,000-foot ash plume, Sabancaya flight level 250. Please do not pole vault the caldera. As we put out all kinds of public service messages here at the Smash News Network, so please don't pole vault the caldera. Today's featured product is the Do Not Pole Vault the Caldera zipped sweatshirt. Yes, the zip front hoodie featuring the fantastic graphics, which are incredibly high resolution, by the way. Let me just show you again. Yowzers. If it's so hot that it's cold where you're located, consider that. You can find the links at smashomash.com. And here is the largest quake of the past 24, this 5.5, just south of the Alaska Range. And this is something I haven't noticed, folks. Look at how round this Alaska Range is. It's like an arc of a circle. Anyway, there's the location of that quake. North of Anchorage, and likely felt significantly there in Anchorage. And leave us a comment if you felt the quake. And what else has been happening? Well, there was a deep quake in southern Alaska, but it was only a 2.6 magnitude. Also a 4.2 out in the Aleutian Islands at depth. The depth 212 kilometers. Again, that 5.5 unlikely to have caused a tsunami as it happened inland in a mountain, actually between two mountain ranges. Small deep quake strikes the Caribbean and Chile, a 4.8 at Chile. And I'm just letting the list scroll here, folks. Not a lot of big quakes, not a lot of activity on the sun or on the earth as far as movements of mass. A 4.3 magnitude quake also happened in Chile just a couple hours before we made the video. Let's get back to space data. And here's the X-ray flux over the past 3 days. No solar flares, no proton strikes as measured by the GOES-16. Here's the GOES magnetometer, which is looking smooth. And again, not a lot of activity, so not a lot of anything besides fairly smooth graphs here on the GOES magnetometers. Here is the top view ecliptic plane field plot showing you the current sheet. And it's actually, you can see this filament here, located right here under my pointer. Significant likelihood that that is going to eject. And I just wanted to show you something here when we show you the line of sight coronal hole plot. So this coronal hole plot, no real coronal holes right now. I'm going to bring this back to 11 years ago. So I want to see what was happening on this same series of dates in 2010 at this quote point, end quote, during the last solar cycle. So let's load this. And you can see how vastly different the sun looked during this same period of time exactly 11 years ago. So the sun was much farther through its solar polar field reversal cycle in 2010, which was sort of at this point in the last solar polar field reversal cycle, although keep in mind the fields were indeed opposite. As you can see, the north is the south and the south is the north, so to speak. And I just wanted to show you that so you understood the difference between the progression of cycle 23 to 24 versus cycle 24 to 25. Or that you could say the progression through cycle 24 versus the progression through cycle 25. So back to today. Here's what it looks like now. And we'll show you the same view on this again here. We'll go to 2010 to show you how vastly different the field situation was back then versus now. So we'll show you the three-dimensional line of sight ecliptic plane field plot as well here. And you may be surprised at how incredibly different that looks. You can see that blue line just squiggling all over the place as opposed to staying right on the solar equator. Completely different. And so let's get back to some data here. The geomagnetism as far as on Earth at a KP of 0, having ramped all the way down from a G1 magnetic storm. A G1 geomagnetic storm here, a KP of 5, ramped all the way down to a KP of 0. And we've got some missing data on the geospace magnetosphere movies. Let's take a look at the real-time solar wind first. And I apologize for those technical difficulties. There was an issue with the software. All right, so here's the real-time solar wind. It was actually my fault, folks. Here's the real-time solar wind. And current conditions are solar wind speed 405 kilometers per second, solar wind density 4.62 protons per cubic centimeter. We did recently see some shifts here in the phi angle, but no real big deal there. BTBZ is fairly uneventful here as well. We did see these little plateaus here. Those look like remnants of a coronal hole wind stream to me, as we see the temperature jumping up here. It looks less like a coronal mass ejection strike than it does little end bits of a coronal hole wind stream. So we can expect the electron flux to come up soon here, as we've seen the coronal hole high-speed stream subside. And so here are the geospace magnetosphere movies, and we're not getting 4 hours of data today. We're only getting like an hour of data. It's only like 45 minutes of data, actually. And I just wanted to show you the space weather modeling framework. So if you head to the Geospace Magnetosphere Movies page and come down to the bottom and click on Details, you'll get a link to this page here, which tells you about the space weather modeling framework, which is how those Geospace Magnetosphere movie models are created. So there are links here as well. And you can find all kinds of other information about the different data sets that are used here. So this is the magnetometer, the electron flux, the solar wind data, all kinds of different data are used to gather these models. Here are magnetic perturbations at the poles, and once again, we're only seeing about 45 minutes of data here. Here's the flattened Earth version of it. And yeah, no comment there. There's missing data for whatever reason. Now, we do regularly stream live to Twitch also, folks. You may want to pick up the app. It's a great app. Twitch.tv/smAsho is our URL here at the Smash News Network. Least busted name in news. And thanks for leaving a comment. Be stoic. I know we're not streaming live yet, but let's go live. And so now we've gone live early here for the cosmology segment. Welcome, Twitch viewers. I would remind you to do one thing: subscribe to our YouTube channel, and make sure you check out our playlists. One of the playlists is Do One Thing. We'd like you to do one thing to improve your life, and then let us know in the comments what that might be. Thanks to all of our subscribers over on YouTube. And don't forget to press like and subscribe if you enjoy the content. Here at the Smash News Network, we need your assistance in order to get the videos out there. Because let's just say we've had some issues at the Smash News Network with gaining subscribers and views. We're also on BitChute. There's exclusive content there, thanks to our BitChute viewers. This is today's cosmology segment, and it should be interesting. We're going to start out with looking at cosmic ray data. So here are the Apatity and Barentsburg neutron monitors, as cosmic rays are becoming a more and more important aspect of science in general, let's just say. So here's the 30-day chart at Apatity. It's a slight uptick there over the past 30 days. Here's Barentsburg, a slight downtick over the past 30 days there. And let's go farther south to Athens, Greece. There's the Athens neutron monitor. And let me just check the life of the stream here. Again, we did start streaming live to Twitch. Again, Athens neutron monitor, fairly flat here over the past 30 days at Athens. Let's go farther south to Mexico City. There's the Mexico City Cosmic Ray Observatory, which is also flat over the past 30. And lastly, we'll look at Oulu, Finland, and 2 Antarctican monitors. There's Oulu. Slight uptick at Oulu, Finland over the past 30 days. Here's DOMB, Antarctica, which is flat over the past 30 days, but it's looking cyclic. It's looking cyclic over about a 10-day period. Here's DOMC, Antarctica, also looking a bit cyclic there. Kind of strange, but flat over the past 30 days. And I would welcome all of our viewers to the Neo Renaissance, and feel free to check out our own website, smAshomash.com. We are alt tech. We won't censor you. And you can find our forum there and so on. The forum's got a cosmology forum. And let's talk about panspermia. It's listed in the title of today's video. Deep crust mineralogy drives hotspots for intraterrestrial life and perhaps extraterrestrial life. So here's Lily Momper and Brittany Kruger and Caitlin Kazar sampling fracture fluids. And they're fracturing some fluids indeed. They're boring some holes, let me tell you. And turns out there's a bunch of biofilms down there, folks. Yes, microbial life underground. And this brings up the obvious concept of what are they eating down there? And it turns out they're eating chemicals, yes. Some of the chemicals that they like are iron and sulfur. Who would have known? Is it possible that life came from space, folks? Well, it took about 2 seconds to find this article. Iron whiskers on asteroid Itokawa indicate sulfide destruction by space weathering. In other words, are asteroids raining down chemicals that support life, life itself, a combination of the two? Is the whole universe just completely not sterile and just dropping life all over the place? Ultimately, the answer is we don't know. But in any case, there's 2 articles about it. And the first one is actually in today's cover story at SciTech Daily. Earth's deep crust mineralogy drives hotspots for intraterrestrial life. Let's pick a random number between 1 and 1031, which coincides with an object. This one is 726. And at the Neil Gorell Swift Bat X-ray Observatory, number 726 is Swift J1749.4-2807, a pulsar. Got to have the occasional pulsar, folks, on the cosmology segments. So there's one. And here's the X-ray output of J1749.4-2827 over the past 16 years. Here's the past 30 days, and we actually saw a very dense series of outbursts here just about 2 days ago, folks. Let's see if we can get some imagery of this particular pulsar. And thanks to that viewer that left a comment about the triple quasars yesterday. Fantastic comment. And we'll have to feature that at a later time, as there were too many things to cover today. So here's this pulsar on the Chandra X-ray Observatory, and it's not showing up very brightly at all there. How about on the XMM? Very dim. Does it show up in infrared? And it is at a very hot spot there. So let's see if Pan-STARRS has any views of it. And there is a view from Pan-STARR. Perhaps a pulsar jet or some other nebulous ionized cloud of gas and dust. By the way, if you're not aware, folks, practically all dust in space is, quote, plasma, end quote. And saying, oh, plasma's not magic. That's my point. And practically everything in space is plasma, unless it's been protected by a magnetic field. Let's see if it shows up in blue light. And not showing up in blue light. Anyway, it's a pretty dim pulsar there. Again, pulsar Swift J1749.4-2807. That's today's featured, quote, random, end quote, cosmology object. And by the way, there are so many stories today that we just simply can't cover them all. So since it's a daily space weather video, we may make another video later today. I'm not sure on that. But there are a bunch of interesting stories here. Fundamental understandings of the universe in the crosshairs because of the two conflicting muon experiments. We talked about that in yesterday's daily space weather video. Also, OSIRIS-REx is about to return back home to Earth. The Mars Perseverance helicopter is about to make a flight. Permanent oxygen rise on Earth occurred 100 million years later than originally thought. Mystery about how particles behave outside a black hole photon sphere solved in a string mystery. So we just can't get to that many stories, folks. Especially when you have technical difficulties, which were all too real this morning. By the way, we are going to also contact LOFAR and request that LOFAR take a look at Cygnus X3 in hopes that it's able to get a view of that as it goes from X-ray loud to X-ray quiet state. And that's today's cosmology segment. We're going to have to say goodbye to Twitch for the remainder of the video. Actually, we'll go live again on Twitch for the meteorology segment. See you there. Next, we're going to look at the electron flux. Here at the Smash News Network, we greatly value the electron flux. Here's a one-year chart of it as measured by the GO-16. And this is measured at about at the F ionosphere layer, by the way, folks. The satellite's not at the F ionosphere layer. The measurement is, it uses radiography in order to estimate the electron density. So here is the 3-day chart of that electron density. The greater than or equal to 2 mega electron volt GO-16 electron flux. It's very low, surprisingly low, and we're expecting a large uptick in this very soon. So you can see NOAA agrees with the forecast here. The green boxes showing higher levels of electron flux. That is the forecast. The yellow diamonds are the observation. Here's a diagram of the Van Allen belts just to keep everybody understanding what we're talking about. And 300 kilometers is way down here at the bottom of the inner Van Allen belt, if you're wondering. Here's a total electron content forecast. This is a visualization of the total electron content between a very high altitude geosynchronous satellite and your possible handset. And we see quite anomalous levels of electron flux here at nighttime around the equator. And we typically do see this. The electron belts get less organized when the electron flux is at very low levels, such as during coronal hole wind streams. Here's another diagram of the atmosphere showing you the troposphere and so on. The troposphere, the portion of the atmosphere where all your weather occurs. Next, looking at the ionosphere, and we've been noting some significant ionosphere anomalies here in the past couple days, and once again we're seeing some large charge ups and charge downs over places like the northern Indian Ocean. And we got to let this one play through here because this is quite a bit of data. As reported by the Australian Government Bureau of Meteorology, some more rapid charge ups and charge downs there over the Atlantic Ocean. And I would expect to see another one over the Pacific Ocean. And keep in mind, folks, oceans emit radio frequency and all sorts of different aspects of the electromagnetic spectrum. So oceans don't just put out heat, they put out all kinds of different electromagnetic radiation, all the way from very low frequency radio all the way up to infrared light. In fact, they even put out some visible light. So, ionosphere looking quite anomalous here. Some large charge downs happening there on the night side. You can see those large red blobs when it becomes just an F layer, where there's only 1 megahertz vibration in that area. Anyway, there's the latest image at 9:30 Universal Time. Let's look at surface winds. And since we're back to meteorology, let's welcome Twitch back to the video. Here at the Smash News Network, we like to talk about meteorology as well. And here is some of it. Here are surface winds of the eastern world. And we see some pretty severe winds here south of Australia, as well as northwest of Australia. And some continuing heavy winds here off the coast of Kamchatka. Here are the surface winds of the western world. And this extremely powerful low pressure system here has moved to the east a little bit, as it's making a huge effect on Earth's weather. And let's take a look at the jet streams here. Here are the jet streams of the west. Extreme meridional jet stream flow once again. Some snow forecasted for the Rockies, we'll get to it. Here are the jet streams of the eastern world. You've got some very cold air being sent down toward the Himalayas there. Let's talk about some comments that occurred yesterday. Now, we don't regularly talk about comments, but because of the talk about geoengineering, let me just briefly talk about geoengineering. Bulgarians firing rockets at hailstorms in order to divert them and prevent them from destroying crops is not geoengineering. A Coloradan organization attempting to divert a snowstorm using a small plane so that it snows in a beneficial place to their skiing location, their ski slopes, that's not chemtrails. Fire suppression systems and the patents associated with those aren't chemtrails. ScopeX, the geoengineering program being messed with at Harvard, is not chemtrails. Planes flying around airports, landing and taking off, producing contrails, aren't chemtrails. The stratosphere is at like 40,000 feet of altitude. And so I'll just leave that there, since we get regular comments about chemtrails. Chad Myers says, I have no knowledge of that practice. Only it's not called chemtrail. It's called stratospheric aerosol injections, SAI, and you can find plenty of research on the subject from respectable sources. So I said, guess what? You can call it late for dinner if you like. There's still no large-scale plane-based spraying program, and using big spooky words like stratospheric aerosol injection impresses exactly nobody. Chad says, and using words like chemtrail makes me rethink your agenda. Please leave us a comment if you think I have an agenda. Same goes for the Nibiru nonsense. Angry Catfish Briggs is where I'll learn about creation. Stick to script, Weather Boy. Okay, we thank you for your comment, Chad. Here at the Smash News Network, we greatly value all of our comments, and we indeed do view them all. And some of them we respond to, and some of them we don't. That's it's part of the reason why we're the least busted name in news. Again, leave us a comment if you think we've got an agenda. Now we're looking at pressure cells here on windy.com. Let's advance this via the Euro forecast. We've got a snow forecast, but here's where we expect pressure to be at 1300 Eastern Time tomorrow. Here's a snow forecast through 6 o'clock in the morning, Universal Time, so 6 o'clock Greenwich Mean Time, 6 Zulu, Wednesday, April 14th. And forecasting a couple feet of over a foot of snow in some spots here in the southern Rockies. I assume all the hot air from Colorado will melt that snow promptly. Keep in mind, this is 5 days out. 5 days is a little far to forecast. That is the GFS forecast for snowfall over the lower 48. Let's take a look at a real-time lightning map. Here's a real-time lightning map. And we've got some terrestrial lightning once again here. Hey, Mobile, go outside and look to your south. You may see some impressive light shows above those cloud tops. Mobile Bay currently getting struck. Anyway, that's lightningmaps.org. I use it when I hear thunder. Let's check the U.S. Doppler Radar Map, and we see this low over the Minnesota-Wisconsin border here. producing some strong storms, as well as some strong storms over the Florida Panhandle. Here's what's going on in the cloud layer. Again, that powerful rotating low there, located over the northeasterly portion of Iowa. You can see that strong rotation. You'll see it even better in the water vapor map. And there's some dry air mixed in there, which is not strengthening the system. It is surrounded by dry air, which is constraining the system. And we've actually got a bunch of cold air being injected down here. So we've got bands of massive pressure gradient here moving across Colorado right now. Should be making for some interesting cloud formations. And we're going to have to say goodbye to Twitch once again. That was our meteorology segment for the day. Thanks for tuning in, everybody, and thanks for leaving comments. Be stoic. Here come bonus features. A very updated image of the sun from the El Teide, Spain observatory, the ground-based National Sunspot Observatory telescope. And you can see that giant filament up there. We're going to show you close-ups of that. I would also remind everybody to check out our own website. You can find all of our social media there and so on. smAshomash.com. Welcome to the Neo Renaissance. Check out our forum as well, smashomash.com/forum. There's a slam poetry contest to win a free month of Patreon for May. It goes all through April, and currently we already have a winner who is a patron. Do you want our patrons to monopolize our patron memberships, folks? I'm sure the Smash team would never want such a thing to happen. So here come the remainder of our bonus features in the form of the colorized magnetogram in high res, the solar intensitygram to show you 0 sunspots. There's the colorized magnetogram, there's the solar intensitygram, and here are some close-ups of the northern hemisphere of the closest star. 304 angstroms showing that filament big time. How about 171 angstroms? So 304 is ionized helium, folks. This is ionized iron. We're going to show you even closer views. And now we've got the Earth scale. There we go. Fantastic. Great view of that filament. Again, the likelihood of this to either eject or collapse are going up. Low levels of solar activity. Last but not least, here is 304 angstroms. Thanks for tuning in, folks. Remember, stare at the sun. Use the proper instruments like our channel, the SDO, etc. Welcome once again to the Neo Renaissance, and may that solar wind be at your back, and that fear-mongering nonsense and crap on YouTube not show up in your subscription feed.